Welcome to today's webinar, Intro to AWS Application Discovery Service. Our presenter today is Nirav Karthari, Principal Consultant for AWS Professional Services. Today with us, we also have Vandana Kumbla, Principal Consultant, as our webinar moderator. She'll be engaging with you and answering your questions throughout the presentation while Nirav presents. Nirav, welcome. The floor is now yours.
Thank you, Ryan. Hi, guys. Greetings. I hope everybody is having a good day so far. Wanted to welcome you guys and really appreciate the time that you're taking out of your busy schedules to go through this 1 hour of AWS Application Discovery Service. We are super excited to talk about the service with you guys. We recently went GA, general availability with the service, about a week or 10 days ago. So it's pretty much available to everybody who wants to use it in a meaningful way. And as Ryan introduced, my name is Nirav Karthari. I'm a principal consultant with AWS Professional Services. One of the reasons I was nominated to do this presentation, as a part of professional services, I've really helped some of the large enterprise customers perform migrations of very large scale, huge migrations, and we internally call them as mass migrations. Talk about 5,000 applications, 10,000 hosts, petabytes of data, so on and so forth. So in that capacity, been there, done that, I really understand the pain that some of the enterprise customers are facing. More importantly, I've also got a lot of feedback working with these large enterprise customers in their journey to AWS. So migration itself being a very touchy topic, given that kind of an experience, I nominated to do this presentation to you guys. What we're going to cover today is a lot about application discovery service. And then along the presentation, I will share relevant experience, not really documented on the slides though, but I'll share relevant experience to make it a little more contextual for you guys who are especially in that journey of migration to AWS. Having said that, let's get started. So the agenda, as you would follow along on your screen, is we're going to touch very briefly on how customers are approaching cloud migration today, and then we'll quickly get into the feedback that we have been listening in from customers. That's to say what really motivated us to write up this service, and then more importantly, what are some of those pain points that the service is going to solve for the customers when they're trying to migrate into AWS. The next and the last topic will be talking about the discovery service itself. We'll get into great length of details on what the service is, how is it built, how does it address some of your concerns, how does it fill some of the gaps that exist today. We'll talk about security, how the service is secured inherently. I can't emphasize enough on how security is a job never done. How security is job zero at AWS. Anything that we build, the first tenet of that new build is security. So we're going to touch upon security. And then we're going to talk through, during the service itself, or discussion of the service itself, we're going to talk through some of the key aspects of the service and outcomes. How do you consume data that the service is generating on your behalf, and so on and so forth. Moving on, here's a pictorial representation of how, at a very, very high level, AWS customers are migrating today. And this is just a pictorial representation. By no means it provides you any details on how migrations are done. This is just to set up a little bit of context on why the service and where does the service really fit within the AWS portfolio of services. So when you think about it, I'm not sure if a lot of you have heard about AWS Cloud Adoption Framework. It's a framework that AWS Professional Services have developed based on our experience working with some of the largest enterprise customers out there. It really brings in our experience, and it's pretty much available to anybody who wants to consume it, especially our partners. A lot of our partners have taken AWS Cloud Adoption Framework and built a little bit of an IP, a uniqueness in their service offerings, all the while ensuring there is that consistent, high quality results when it comes to delivering engagements to the customers. So aligned to the Cloud Adoption Framework is the migration framework that you see on the screen. It typically starts with a strategy, and the strategy is all about what's the existing IT estate that you have, and what is it going to end up transforming into. Think about customers who are approaching a data center lease renewal in a year or two. Think about customers who are about to do hardware refresh. Think about technology out there in your data centers which is approaching end of life, end of support. So any one of those compelling events, and you strategize, you look at your existing IT and you develop a plan, whether you're going to sign up a lease again with a data center or a colo provider, whether you are going to spend that CapEx going through the hardware refresh cycle, or whether you are going to adopt a service that's available, such as AWS services. Once you identify a strategy of what is going to happen to your IT assets, once you define a target state that you want to reach, you will start planning. You will start planning on how would you accomplish your desired end state. And one of the starting points that we have observed in most of these planning exercises is discovery. You certainly want to know what instances are running out there, what servers are out there, what are the typical utilization patterns. Have you overcommitted resources? Are you underutilized? Do you have an opportunity to right size and save cost? Is there agility that you can be introducing in your environment? So on and so forth. So usually the planning phase begins with discovering your IT asset. You want to identify every single server, whether it's running in the data center, whether it's running in a closet, or whether it's running in one of the developers' desk. You want to know each and every server out there so that you can plan around transforming or migrating that server into a new state that you're defined during the strategies phase. Once you've done that, you get into a cyclical phase of building out the target environment. And there are multiple ways in customers have done it. A typical approach listed over there is on a per application basis. You will go ahead and identify a design. You will identify your opportunities to go ahead and adopt agility if that's what you want. You will right size your target environment if there's an option to do so. You will go ahead and loosely couple components of your application architecture because that will allow you a lot more flexibility, agility to do things like horizontal scaling. So you will, on a per application basis, go ahead, design your target state environment. You will migrate it or transform it into a target state environment. You'll validate it. All of that happens during the build phase. And then once you're done validating an application on the other end, once you light it up in AWS, you will hand it over to the operations team for ongoing support. Think about that as a run phase, or keep the lights on. So those are the typical phases that customers go through. We'll move on to the next slide. When they do that, when customers try doing that on their own, this is what we have heard. And as all of you would kind of agree, migrations, especially cloud migrations, can be very complex, and it can quickly become pretty costly affair. A typical data center migration can involve thousands of workloads and tens of thousands of servers. That's one of the biggest problems right there. You have 1,000+ application which runs 2,000 plus servers, how do you detect each one of them? How do you identify interdependencies? Because you can't just pick one application and migrate it. There will be quite a few other applications that actually depend on that application. So you need to identify a pathway whereby either you take a risk mitigated approach of identify an application which has the lowest possible impact on your users. It is least business critical because probably it's not a revenue generating application. Um, it has fewer number of dependencies. It has fewer number of users and so on and so forth. And then move that first and then eventually increase complexity on all of those aspects. But nevertheless, you need to identify all such interdependencies, which is very poorly understood today. If I were to conduct a poll right now asking you how much matured is your existing CMDB, I probably know the answer. I probably know the answer. There's not a super refreshed source of truth available whereby you can go and pinpoint how does one particular application behave and what are its interdependencies and so on and so forth. So that becomes challenge number 2. Identify all workloads and then identify how they're related to each other. And then that itself leads into the third one, which is how do you determine what's the best path for legacy applications? Think about one of those applications architected on a risk architecture. And all of you are aware, AWS doesn't support risk architectures. So that becomes your challenge. How do you transform a risk-based system into an x86 architecture, either during or pre-migration? And then last but not the least, identify all application inventory and dependencies. If you're doing it manually, imagine the amount of time it's going to take. Imagine the amount of effort it's going to require on your side. Imagine the number of resources you will need to go and manually collect all of this information and then keep it constantly updated. Because app owners are not going to stop working, waiting for you to finish migration. So if you're manually doing this, if you're managing this, if you're collecting information manually, that itself could become complex, time-consuming, not so refreshed, high effort, a lot of resource type requirement. So all of these, are some of the challenges that our customers shared with us pretty loud and clear. They want an answer on how do we do this. And the answers on the next slide, what we did was, if you guys recollect, we had tools that would assist you during the build and run phases of the migration. For example, if you were to do a lift and shift, pick an existing workload and without doing too many changes, without changing the code, without doing legacy modernization, without changing the architecture itself, if you were to just forklift an existing workload and drop it into AWS, AWS offered a tool called as EC2 VM import export. And as the name suggests, it allows you to either import or export an existing virtual machine in your data center into EC2. What's really happening in the back end, technically though, is think about you pick up a VMDK or an OVA file and you're converting into an AMI, an Amazon Machine Image. And you're doing this with a no-fee tool available to you called as EC2 VM import or export. And likewise for databases, guys familiar with AWS would know we announced beginning of the year and we went GA with the database migration service. It's a really cool tool, allows quite a few different use cases that you might have. For example, it allows you to migrate your existing database. If it's Oracle, Microsoft SQL, MySQL, PostgreSQL, one of those variants, one of those technologies, it allows you to migrate an existing on-prem database into a database running on EC2. What's more, it allows you to do a schema conversion. Imagine a situation that you are running MySQL on-prem and in your migration, you want to adapt to Aurora, which is an AWS proprietary database. It's 100% MySQL compliant, delivers commercial grade performance at less than a tenth of the cost of any commercial product. So the database migration service allows you to do schema conversion during migration. You can convert an on-prem MySQL into an Aurora using the tool without changing any of your applications because it's MySQL compliant, 100%. So, and then when you think about the run phase of your environment, there are quite a few tools available to use, such as CloudWatch. Think of that as a monitoring system. AWS Config, think of that as a CMDB CI relationship, or an asset management system for AWS Cloud. And then there's an extension of AWS Config called as AWS Config Rules, which allows enforcement of governance policies. So anyway, the point being, there were tools available for build and run phase of your journey. What we did with AWS Application Discovery Service is we introduced a tool in the planning phase of your migration. The way it's positioned, it helps you in doing a discovery and planning even before you start migrating your environment into AWS. The service itself is purpose-built, and there's a little bit of an emphasis in purpose-built. There are quite a few partner tools, solutions available out there, and quite a few of those tools are pretty mature. They will not just perform a discovery and planning for you, but they would also assist you in performing migration, say, for instance. But when we looked at offering a service within the AWS portfolio, we realized we need a tool which was purpose-built only to assist in discovery and planning phases of the cloud migration. So AWS Application Discovery Service is purpose-built, which helps you streamlining the planning process of your cloud migration. Moving on to the next slide, what the tool really does is automates data center application discovery. So there are three distinct aspects in which we've broken up the capabilities. One, it identifies application inventory. Think about what's a server and what's the CPU and what's the memory and disk space and I/O allocated to this server, and what are the typical applications, COTS or custom, running on top of this server. That's the first aspect, identify application inventory. The second aspect is map application dependencies. Now that we know what's running on a server, we're going to further drill down, looking at what is really talking to that process, or what is this server talking to somebody else. Identify every process and every port, whether it's a source port or a target port, and thereby creating a map of interdependencies of applications for you that assist you in planning migration. And last but not the least, baseline system and process performance. Imagine situations where you are either undercommitted or overcommitted, underutilized or overutilized. You allocated 8 gig of memory, which is barely consuming 4 gig. And that's your opportunity right there to right size an instance with your migration. So we will assist you, we will provide you, the discovery service will provide you enough of data for you to make those intelligent decisions on what's the baseline performance of the system and how each process is consuming system resources, and what are your opportunities to optimize or right size along with your migration phase. Moving on, the way the discovery service is being engineered, it's an agent-based system. You deploy agents on the source host, and the agents are available in Windows and Linux flavors. So if you're running one of those hosts, which is anticipated to be target of migration, you will go ahead and deploy an agent on the source host. The agent will then capture all the information, all the data that it is supposed to, such as system inventory, performance, dependencies, and populate a discovery database, which is a store running in AWS. Obviously, because it's transferring data from on-prem into AWS, there's a lot of security built around that itself. The data is 100% encrypted, both in transportation and at rest. Once the data is populated in the Discovery database on the right side of the screen, you're free to interact with the data using APIs. So you will run APIs, you will consume APIs, which are available with the Application Discovery Service to go and query the data that's stored in the Discovery database. There are two separate ways in which you will interact with the data. Think about a near real-time interaction with the data, which is only possible through APIs. Think about an offline interaction with the data, which could be you can dump all of the inventory information, all of the data pertaining to your environment into a CSV or an XML. And once you export into one of those formats, you're free to use whatever you want. You're free to consume it however you want to consume it. And one use case that we're going to talk through as we progress in the presentation is you can use one of those open source visualization tool to ingest the CSV or XML into an open source visualization and draw maps. And we'll talk about it as we move along. But at a very high level, that's how the service operates. An agent sits on the host, collects data on a secured channel. It dumps all the data into the Discovery database running in AWS, and you access your data through APIs. Moving on, let's talk about every component of that. So the first component itself that we want to talk about is the agent, the piece of software that you will run on your host. Think about that agent as a binary or a piece of software which is deployed using whatever is your choice of or whatever is your existing software management tools. Think about the SCCMs of the world, which most of the enterprise customers have deployed. So we don't want you to change any process or any tools or relearn any new deployment mechanism for you to roll out Discovery agents across your environment. As I stated on the previous slide, the agent supports both Windows and Linux hosts. Because it's a piece of software, a lot of customers have this question around what is the overhead of the agent. During preview and in all of our testing, we have found out that there's a very, very small minimalist footprint or overhead that the agent will generate on your system. And you're welcome to use it in your non-prod environment to test it out on your own. One of the best security aspects of the tool that I love the most is the agent allows two distinct types of configuration. You can run the agent in an offline mode. When you run the agent in an offline mode, the agent behaves as it is supposed to behave, that is, capture all the relevant data, but it will not store it into AWS. It will dump it in a flat file on the local host. Think about that. When you dump all the data that the agent has collected on your behalf and store it in a flat file on localhost, that gives you an opportunity to go and inspect the data that the agent is going to store in AWS. So for all you security conscious customers out there, here's a great feature for you. Go inspect all the data that will be eventually shared with AWS. And once you are rest assured that there's no critical data pertaining to your system that we are capturing, you can go ahead and toggle the agent into an online mode. And in online mode, it will go start populating the Discovery database in AWS. So it's a great security feature for you to go inspect, for you to go try it out before you turn it on into your environment. And the last thing that I want to talk about is the Discovery agent itself is proxy agnostic, which means the agent itself doesn't require any configuration. If the underlying host can reach out to internet on port 443, either direct or through a proxy, the agent will communicate. Let me say that one more time. It's proxy agnostic if the underlying operating system can communicate outbound, one way, outbound only on port 443. The discovery agent will pretty much pick up that information and communicate with AWS Discovery Database on port 443 outbound. You don't have to really punch holes, allowing anything inbound into your environment. Move on to the next slide. Here's a subset of data that the agent will capture. It'll capture all infrastructure and application level information. It will capture all inventory information, such as what softwares or what carts are installed on your system, what custom ports are open, and what custom applications are running on your host. It will also capture information about the application, the running application, and the processes such as user information, group information, list of kernel modules, operating system specific information, so on and so forth. It will collect the system and process performance and resource utilization, such as CPU, memory, all created and stop processes, disk and network performance. And then last, it'll track all network activity. And that's how it really identifies the interdependencies. For example, it'll look at all TCP and UDP listening port and map it to the process running on the local host. It is compliant with TCP version 4 and version 6 or v4, v6 connections. It can also capture NIC information. Think about one of those legacy softwares you're running, which is licensed on a particular NIC, and thereby you're running multiple NICs on a given host. The agent is capable of capturing all of these NIC and associate processes or connections with each one of those NICs. Makes it way too easier for you to define a target state environment. Moving on, we'll talk about some of the features. As I alluded earlier in the presentation, for the time being, the only way for you to interact with the discovery database is through APIs. But that's a good part if you really think about it. The API infrastructure that AWS has created for the rest of the services, which is pretty mature, highly available, highly performant, Discovery Service uses the exact same API infrastructure for you to use APIs and interact with your data. There are quite a few operations that the APIs will support. A few of them are listed on the slide. For example, list configuration item. When you run this API, the output is all the discovered host will be reported or will be listed as an output of the list configuration item API. Likewise, you can issue or you can use a get configuration attributes, and as the API suggests, it will go ahead and provide you more detailed information about an individual host, an individual discovered host, such as what's the CPU and what's the memory and what's the min max and what's the average utilization, so on and so forth. You can also use export configuration. That's how you will dump or you will export all of the data in the discovery database into either a CSV or an XML format. And that's the data dump that you can then use for offline analysis, which could be either using some visualization tool that you already have or open source visualization tool, or consume data however you want to consume it for analysis. The last API that I want to talk about is create and delete tags. Think about that as a very powerful feature available for you to tag instances that are running on-prem. It's a great feature when you think about it. And the way we have consumed those tags, there are about 25 tags supported today with the service. And the way you can think about consuming those tags is once you discover a host, you can associate appropriate metadata such as this host is a part of HR application. This host performs the function of a web server within that application group. The server is supposed to be cut over scheduled on 25th of May. The server belongs to Nirav and therefore coordinate with him when you want to take the server out for migration, and so on and so forth. You can pretty much programmatically, using metadata, using tags, build out most of your migration plan, your migration strategy into the host itself, into the discovery database itself. Very great feature. And then what we've also done is we've written up some command line interfaces using the APIs that we already have for you to perform CLI operations using those APIs. And here's an example that I want to walk you through. Imagine that you're running a LAMP stack on-prem. The Application Discovery Service is capable of identifying all dependencies within that LAMP stack. And when you really think about a stack such as a LAMP stack, what you're talking about is there will be quite a few workloads, which comprises of a web server running Apache, a database server running MySQL, a PHP server, so on and so forth. There could be additional dependencies within that stack, such as you might be using LDAP for authentication, you might have load balancers, you might have DHCP servers, syslog servers, so on and so forth. And then you want to identify and analyze dependencies and right size using API operations. Think about something as basic as identify this LAMP stack, identify performance, export them into a CSV so that you can import them into something as basic as in Microsoft Excel. In a typical migration of that type, what happens is either you, if you are a DIY fan, or if you have contracted one of those SI partners or AWS professional services, what we would do is once we discover this stack, once we identify a target state, we'll go ahead, we'll build out a VPC, a subnet, a target state environment or an architecture in AWS. We will set up a connection between your on-prem and that target state AWS environment. And then we'll plan migrating into AWS, which could be run your Apache or PHP into Amazon EC2. You can swap out your hardware load balancers with ELB and MySQL with DNS and so on and so forth. So this is a typical example of a LAMP stack right from discovery to migration into AWS. And we're going to walk you through how the tool will assist doing something of this nature. Moving on to the next slide, the first and foremost CLI example over there is I'm doing a very basic list operation. And the filter that I'm passing along with the list operation is show me everything that you have discovered and then group them by applications. And the last two lines on that example is the output. And as you can see from the output, we were able to identify 6 servers are web servers. And how did we really claim that? It's claimed based on identifying a process running on those 6 servers, which is either Nginx or HTTPD. And then likewise, the last line shows that we identified 3 servers are running databases, and the way we identified is because there's a process called MySQLD running on the server. The agent identified those processes, and therefore the agent is making a recommendation for you, saying that there are about 6 servers which are running web, and there are 3 which are running databases. Let's move on to the next slide. Here's an example of me performing a CLI operation, and the filters now changed to list me any server that participates in a stack called as a LAMP stack. What it really means is to qualify a workload to be running in LAMP stack, it should either run Python 2.7 or Nginx or MySQLD. Any server that we identified belonging or running one of those services, we went ahead and we listed them as a part of the length stack. Now remember, it's still not providing you any affinity. It's just listing out systems that matched the filter criteria. Moving on to the next slide. Here's an example of how do you identify affinity. And what I mean by affinity is, in the previous slide, there were quite a few hosts listed out or qualified because it either ran MySQLD or Nginx or HTTPD, one of those processes, one of those qualification criteria. What I'm doing on this slide in the examples is I pick up one of the hosts and then I issue a command called list me all the dependents on this particular host. And then in the output, you will see lists out a particular server which is running MySQLD. The second operation, the second CLI example is I picked up the dependency information or the dependent output from the previous command and I issued a similar command to that one. So in a cyclical fashion, what I'm doing is I just picked up one host. I tried identifying everything that's dependent on that. It gave me something else, and I issued a similar command on that something else. And that's how I eventually built out the affinity, the application affinity. Once I identified all of those affinity, the third command, the third example on the screen was I took all of those affinity information and I put a tag called wave1. Right? So what's happening is you don't have to know every application. You don't need to know affinity. All you are doing is you need one host as a starting point. You build out all the affinity information based on a single host. And then once you were done building out that affinity or dependency tree, you tagged them together so that in future you can perform a list operation on the tagged information. So now if you were to do a list host that are having a tag wave1, it'll automatically list out all the hosts. Very powerful. Oh, and there's the example. So I moved on to the next slide and I performed a list operation for every host that participates or has a tag called wave1. In the second example, I did a describe host, which means tell me in more details information or intel about all the hosts that has a tag called wave1. And what I got back was an agent ID, a host name, how many CPUs, how much of memory is provisioned versus utilized, so on and so forth. And I can consume this data, this output, to right size or do an instance type matching for my AWS instance type. This will really assist me in executing the migration itself. We'll move on to the next slide. The way the service is available, it's only available to you through either professional services or SI partners. And the way it'll really work is you still have to go ahead and whitelist the service. So you will log onto your account. You will make a request to whitelist you or white label you. And then somebody in the back end from the service team from AWS will allocate either a professional services consultant or an SI partner. Now that doesn't mean you have to end up signing a new contract. That doesn't mean you have to pay any additional service fees to either the professional services or SI partners. It just ensures that if you were to have any technical challenges using the service itself, the professional services consultant or the SI partner that is assigned to you, if you don't have one, will assist you, with deployment, with implementation, with an ongoing operation with regards to application discovery service itself. So one more time, you just log into your account, request whitelisting. If you have an existing professional services consultant or SI partner engaged, you provide the detail to us and we whitelist you. If you don't, we assign you one and we whitelist one for you. The service is available at no extra fee to you. There are some soft limits around the service itself. For instance, you cannot run more than 10,000 agents in your environment, of which only 250 can be active at any given point in time. And you cannot be ingesting more than 10 gig of data a day. One more time, up to 10,000 agents in an offline mode, 250 online, not more than 10 gig of data generated in a day. That's a soft limit. If you have a legitimate use case where you need more, open a trouble ticket, work with your technical account manager, your account executive, your professional services consultant, whatever is your preferred way of communicating with AWS, go ahead, make a request, identify your use case, and we'll be happy to raise those limits for you. I'm going to quickly walk you through a couple of slides on visualization itself. I'm using a free tool over here. I don't remember the name of the tool. I guess it was Cytoscape, but that's not important. What's important is what I did. Was I used an API to export all the discovered data into a CSV, and then I imported that CSV on my local machine, on my desktop, on my laptop, into this open source tool, which I downloaded like an hour before I imported the CSV. And then I started running some of those queries. For example, in this example, if you look at the font's pretty small, but if you look at the top, left of that navigation pane on the left-hand side of the screen, you will see what I'm doing is I'm issuing, or I'm filtering everything where the source is Python and the destination is Nginx. And then it obviously, will go through the entire CSV and list out or plot every host, every instance, every workload that match that filtering criteria onto the screen. So the screen is a little difficult to read, but all those yellow colored instances on the screen are instances that really match that filtering criteria. That's how you want to read it. Everything in yellow, everything highlighted in yellow is what really matches that filtering criteria. On the next slide, on the next slide, what I wanted to highlight is I just did a zoom in. Again, if you're tracking along, look at the bottom left of the navigation pane, and you will see I zoomed into the one of those environments which match the filtering criteria. And what you see on the right-hand side of the screen is everything, again, that's yellow, matches the filtering criteria. What's important, what I want you to see is those pink triangles. Those pink triangles identify a system which is communicating to one of the hosts, but the color pink identifies that there's no agent running on it. Take a minute to think about it. You don't have to explicitly go and know each and every server in your environment and deploy agents. You can deploy agent on one of those hosts that you're aware, and then when you start querying the data pertaining to that host, you will get to know what hosts are participating or communicating with the target system but doesn't have an agent. That itself, those pink triangles itself, could become a project plan for you to go deploy agents on all of those participating servers, participating hosts, and eventually build out your entire environment with those agents running in there and then providing you this level of details. I think that's my second last slide. The application discovery service itself integrates with a lot of partner solutions. It complements a lot of existing partner solutions out there. So you're not asked to swap out your existing solutions. This is just going to help you, assist you, complement whatever you're using today. It provides you a very rich set of public API operations and open data formats. And that's what really enables it to coexist with other tools. It can integrate with any existing discovery tool that you have running in your environment. And it can publish information, or you can have your existing tool publish information into AWS Discovery Database. You're not forced to use the agents either. If you have one of those tools, one of those partner solutions that can publish information into AWS Discovery Database, you can continue using the discovery tool, publish it in database, and then use rich API operations and everything that you saw in the previous slides to assist you in planning and discovery aspects. It can also work with migration tools. So the partner solutions available in the market today are in the process of integrating. Some of them have already integrated with the AWS Application Discovery Service. So you can use Discovery Service in conjunction, integrated with one of those partner solutions to provide you with an end-to-end migration. And it complements existing migration frameworks. So if you are working with one of the SI partners, they can pretty much continue utilizing their framework complemented with AWS Application Discovery Service to provide you better level of service. With that, we conclude today's webinar. Thank you, guys.